All right. Looks like people have mostly funneled in, but as they're coming in, I'll like to welcome in EnergyX founder Teague Egan. Thank you so much for joining me today.
Thank you, Eric.
And before we dive right in, again, I'll do a little bit of housekeeping as I always do. So thank you so much for everybody for attending. Really excited to have Teague here and talk about EnergyX. As always, EnergyX is actively fundraising on the Netcapital platform. So you can go directly to netcapital.com and search the companies for EnergyX, or you can go to netcapital.com/companies/EnergyX. And I actually just added that link into the chat feature. Also, as always, we want to make this as interactive as possible. So please do use that Q&A functionality built into Zoom. There is a chat feature, but Q&A works a lot better for tracking and managing the questions. So please do not hesitate to click on Q&A, ask a question there. We'll try to get to as many of those questions as possible. So with that being said, that basically covers our housekeeping items. Teague Egan, why don't you hop in here, tell us a little bit about yourself or about EnergyX, and then we'll talk about yourself and keep going from there.
Cool, yeah, absolutely. Well, first, thanks everybody for coming. Looks like there's about 67 people, so happy that everybody's taking the time out of their day to hear what I have to say. But yeah, about EnergyX. So I started the company in 2018. I knew that I wanted to be in the renewable energy sector. I just think it is going to be one of the biggest industries of the next 20 to 40 years. And it's something that I enjoy every day, waking up and working on. I think that it's, I can legitimately say that I'm changing the world for the better. So I like to be able to wake up and feel that feeling every day. EnergyX is focused on batteries and the battery material supply chain. We're looking to make that more efficient, the same way that computers have seen tremendous progression from the early days of Apple to now, and computer chips that have increased in storage and decreased in price. I think that we're going to see a similar kind of trajectory for batteries, that batteries become much more efficient and are a lot less expensive. And, that is going to be a really important area in the renewable energy transition.
Yeah, absolutely. That's really, really interesting. You're talking about next generation battery tech, direct lithium extraction. Before we take a deep dive into kind of the problem solution and the rest of the investor questions, tell us a little bit about yourself, Teague. Who's Teague Egan?
Well, I was born in Florida and born the son of a serial entrepreneur, which I kind of inherited. I went to school at USC, the Marshall School of Business in Southern California, with a focus on entrepreneurship. And then lived in Los Angeles for 10 years. I love sports. I love music. But I am an intense worker. And for the past 3 years, I've probably worked 16-hour days on EnergyX. I'm logging 100-hour weeks right now, and I love every minute of it. And really, my goal right now is to turn EnergyX into a unicorn, and then hopefully someday take the company public. But EnergyX is my wife and girlfriend right now. So. I live in Puerto Rico now. That's where the company is based. And we're opening up a lab in Austin, Texas. So currently we have 2 labs. We partnered with the University of Texas, which is where the original IP of the company that we licensed came from. And then we partnered with a company out of the Bay Area called Membrane Technology and Research. And we have a lab in their greater facility. So we work out of those 2 labs. But as this Series A comes together, which is, partially being raised on Netcapital. I think we're at about 900,000 there. The whole round is about is a 10 to 12 million dollar round. We're building our own independent 15,000 square foot facility in Austin, Texas, which is where I am now, and I'll be splitting time between Austin and Puerto Rico.
That's great. And I know you are an early investor in Tesla and a big fan, and you have been actually compared to Elon Musk by the BBC. I'd love to get your thought. How does that feel to come from a family of serial entrepreneurs and be compared to arguably one of the greatest entrepreneurs in history?
Yeah, I mean, I think the greatest, but it's a crazy feeling. I mean, he's my inspiration for all this, right? I started this company. I first of all, I invested in Tesla back in 2013 at $8 a share. That's post split. So I invested at about $40 a share, and then it split 5x. So $8 a share at the current share price. And like a few months after I invested, the stock went up by, I think it was like 50%. And so I bought a Tesla. And so I've had the same Tesla Model S since 2013. And that's what really inspired me to become passionate about renewable energy. And I started the company. My aha moment was New Year's 2017 going into 2018. So about 3 years ago, as of this past New Year's. And, I get these notifications on my phone on Facebook. They're like, you were here 3 years ago. And like all these pictures are popping up of me when I was in the salt flat, when I first discovered where lithium is produced from. So that's kind of a surreal moment. But, as I started this company, some of my friends would like say, oh, like call me Elon Musk and whatnot. And then, when the BBC wrote this article and compared me to him, it was just like, it was pretty mind blowing. I mean, he's the greatest entrepreneur. He's not only the richest man in the world, but you only become wealthy like that when you do something that changes humanity. Like you look at what Bill Gates did and how he made computers absolutely changed humanity, right? And are arguably why we're advanced as a civilization as we are today. And then Jeff Bezos came along and created such an easy method of retail and commerce, completely changed the world. And now you have Elon Musk, what he's doing with the transition of renewable energy, and then SpaceX, which could even arguably be a bigger company than Tesla. I mean, he is pushing humanity forward, and that is what I respect about him the most. And I'm just trying to ride on his coattails, like we're producing products that I hope that I believe are going to be valuable to Tesla. It's you have to create value, right? And I think that I look at the electric car revolution, and I'm trying to provide one small piece to that puzzle and make that puzzle just a little bit more efficient in terms of more abundant lithium and cheaper lithium, and then hopefully better batteries, which is our second product. But yeah, he's a remarkable individual, and I look forward to seeing what he does with all of his companies in the future.
Absolutely. And so we do know, I see the Q&A in the chat, and we will definitely go into competitive landscape, revenue model. But before we get to those questions, why don't you tell us a little bit about how do you see the problem in the puzzle pieces that you're describing, and how is EnergyX the solution?
So I recognized the problem when I was first down in Bolivia, which is part of the lithium triangle, where a majority of the lithium, between South America, in Australia is where a majority of the lithium is produced that goes into all the batteries that power our consumer electronics and now our electric vehicles. And there's two methods of production. So there's hard rock mining, and then there's brine extraction. And lithium is a salt that is mixed in with a bunch of other salts in really salty water. And I was down, and I think that the brine has a lot higher ceiling for lower capex, lower opex, lower cost per ton eventually than hard rock mining. I think there's a lot less technology that can be introduced to lower the cost of hard rock. So, brine extraction is where I think the majority of our lithium in the future is going to come from. And when I found out how lithium is currently produced, it was just remarkable to me. It's such an inefficient process. You can almost think of it as if we needed to build a city of houses to house 1 million people, and we had to build all the houses by chopping down trees with an axe. Like, then somebody said, I should probably figure out a better way to chop down all these trees, and they invented a chainsaw and did it in 1/100th the amount of time or whatever it was. That is literally the problem that we're facing with lithium. And the reason is just because we haven't needed that much of it until now. It takes 10,000 iPhones to make one electric vehicle. So if you're trying to make 1 million electric vehicles, that's the equivalent of 10 billion iPhones. So before cars, when consumer electronics were all we needed lithium for, we didn't really need that much. Now we need a lot. So the method of manufacturing that lithium also needs to raise its level of competency. And that's where we started developing technology that could increase the efficiency of lithium production.
Yeah, no, that's really important. I think the comparison between the level that we needed before and the level that we would need going forward. And when it comes to efficiencies, I see from your offering page, production takes 18 months on average, and you only extract 30% of the total lithium from that salt brine in those massive evaporation pools. That sounds incredibly inefficient.
Incredibly inefficient.
So tell us a little bit about your tech and how it improves that efficiency, and what are some of those metrics that you're seeing?
Yeah, absolutely. So these ponds, first of all, are massive evaporation ponds. And if you've ever flown into San Francisco, you've probably seen them coming down. But the ones that produce lithium are even much bigger than that. So these ponds in South America that SQM, which is one of the larger producers, uses, are 15 square miles. And they have two 15 square mile systems. To put that into perspective, Manhattan is 15 square miles. So they're bigger than the entire city of Manhattan, from downtown to north of Central Park. So they're huge. It takes a lot of people to run them. And while they have lower energy costs because they're using the sun to evaporate a lot of the water, that's made up for in labor costs. They have about 2,000 people working this pond system in shifts. So it's in the middle of the desert. So they have 1,000 people come out every week, and then they have 2 shifts. So they have like 2 8-hour shifts, and then you get a whole week off, and then another 1,000 people come in. So there's a lot of OpEx in terms of that. But where I thought that we could make a play and create a disruptive technology to improve this was through membrane filtration. So ultimately, we're trying to separate the lithium salt out from the rest of the salts. But there are technologies such as reverse osmosis and desalination that remove all the salt from seawater. So you can make fresh drinking water out of seawater. It's a technology that's been reduced to practice, right? And I said, if we can have a membrane that separates all the salt, then why can't we have a membrane that can target specific salts in this mixture? So I went out and started searching for people that were working on this problem, and while I'm the business mind and kind of like, I guess you could say the visionary behind this, you know, I went out and found the most brilliant scientists and engineers that were actually working on this problem. You know, these are PhD electrical chemists, electrical engineers, chemical engineers, electrochemical engineers, people that are working on nanotechnology, and assembled this team that was working on this, partly from the University of Texas, and was able to license a bunch of our original core IP from the University of Texas, and then have since filed additional IP around that. And you know, one other point that I want to bring up is that, so while the ponds are theoretically inefficient, the lithium producers have already spent a tremendous amount of capital on them, right? And one of the mistakes that I made in the beginning was I said, we have this brand new technology that is going to replace all the ponds. You know, it's great. You guys need to get this. And when I went and pitched all of the lithium companies, they all pretty much laughed me out of the door. And I, you know, came out like scratching my head, like, you know, I have this great technology. Like, why do you not want to use this? And what I realized was just that they've already spent hundreds of millions, if not billions of dollars on these ponds, and that we needed to create a complementary technology in order to be able to go to market. And that ended up being a good thing. You know, now, instead of building something that just replaces the ponds that costs 100 or 200 million, we have something that the capex is like 10 to 20 million for our go-to-market, because it works with the ponds and still is able to maintain this 90% recovery rate. And now we've signed contracts with 4 out of the top 10 lithium producers. So it was an important kind of pivot that we made that, you know, I credit a lot of my science team for being able to recognize that. But, you know, being a startup and being nimble and saying, you know, we need to reanalyze our approach because we just got turned down by every customer, and we need to figure out how we can actually provide value to the customer, was kind of like the turning point in, we might not make it, to now we have all these big contracts and are about to deploy pilot plants into the field and like are well on our way.
Yeah, and before, and I usually actually talk about team kind of right about this point, but there's a lot of interest in learning about the competitive landscape. So hold tight, chat and Q&A. We're going to do that right next. We're going to move that up a little bit, give the people what they want. But before that, I'm looking at your offering page, the system that you have compared to the 30% efficiency that you were seeing before. I'm saying what 90%, 3 times the amount of lithium as traditional evaporation ponds.
By the way, who is this guy? V-Pool, go out.
We're not gonna worry about it. But
he can leave the chat. We don't need V-Pool.
But if you want to tell me a little bit more about you know, the metrics. So I'm seeing the 90% recovery rate compared to 30%, and then the timing gets cut dramatically as well. Is that right?
Yeah. So the reason, so the way that we increase the lithium recovery rate is mainly due to one very important thing. So in the evaporation ponds, it goes through a series of the ponds, right? And the different salts are precipitated at different points along the pond cascade sequence, right? So it's the brine's pumped out of the ground, and then it goes into the first pond, which it sits for a few months, and about half of the water is evaporated. And sodium chloride is the first salt that's precipitated. So you essentially get rid of most, if not all, of the sodium chloride. They move all the brine to the next pond, and then they scoop the sodium chloride out, and then they refill that pond with fresh brine that comes out of the water or out of the ground. In the second pond, the potassium chloride is precipitated out, and then they move the brine to the next pond and scoop all the potassium out. Then the third, it's magnesium, but at a certain point, between the third and fourth pond, the lithium starts to co-precipitate with the magnesium. And that's where they see this 50 to 70% loss. But they need to go through that because they need to concentrate the lithium up to about 6% of the total solution so that they're able to crystallize it into the final product, which is either lithium carbonate or lithium hydroxide that they then put in, that they sell to the battery cell manufacturer, right? So we said our generation 1 technology, which is the complementary technology that I just described, our system is like a plug-in that sits right before this co-precipitation happens, right? So now we're treating a substantially less amount of the initial feed brine. So in the beginning, they pump out like millions of tons of brine, and then all this water is precipitated or evaporated in the first 3 ponds, and all this salt is precipitated out. We come in just before that. We treat a significantly less amount of the initial feed brine, about 1/30th, and that's why our CapEx is so much lower, but we still maintain that 90% recovery rate because we avoid all of the co-precipitation. So in that scenario, we don't decrease the amount of time that we would otherwise if we replaced all the ponds, because we still use the first 3 ponds. And this is attractive to the biggest existing producers because now they don't have to get rid of all the sunk costs, but they get to increase their output by 2 to 3x. So that's generation 1.
Yeah.
Generation 2, once we have maximized the capacity and efficiency of the existing ponds, and you can get no more lithium out of the existing ponds, nobody wants to go and build more ponds. They're environmentally unfriendly. They have, a lot of OpEx, and you need a very particular environment to do this. Pretty much the desert in Atacama in northern Chile is the only place. So that's where generation 2 comes in, and that's where we're creating membranes that can do the initial separation for that sodium and potassium that I mentioned get precipitated out in the first pond. So we'll be able to take the feed, run it through our first membrane, then run it through our second membrane in a series of membranes, and then just come out with a final product. And that's like a full enclosed mechanical separation process.
Wow. No, that's super interesting. And I had the good pleasure of studying abroad in Buenos Aires and seeing those salt flats in person in Salta and Jujuy and some of the neighboring areas. And they are massive. And I never thought about the OpEx of it. Okay, so quick housekeeping reminder, you can go directly to the link that I added to chat. That's netcapital.com/companies/EnergyX. There's a lot of information there. There's opportunity to invest with the push of a button in a couple of populations and some fields. So do not hesitate to do that. Very grateful to have Teague Egan here to answer your guys' questions. So let's start going into some of these potential investor questions, and then we'll circle back to team and some of those things after. So overwhelming majority of these questions are who are your competitors? How do you differentiate yourself from the other players in the space?
Cool. So some of our competitors, so a lot of these big lithium producers are trying to develop technology, but they're also looking towards companies like ours to license or partner or buy our technology. So you could consider the big lithium producers competitors, in that they're always trying to make their process more efficient or come up with technology to make their process more efficient. But some of the direct lithium extraction startups that are entering this space, like, I'm not the only one to think of this problem, right? Like, I'll be the first to admit that. So some of them, one is called Lilac Solutions. Like, if you want to go look up some of our competitors, Lilac Solutions is one of them. Adionics is another one. Tenova is another one. Aramet is another one. But the big difference between us and all of these companies is that we are focused on a membrane separation technology, whereas most of them are looking at a technology that falls in the ion exchange or ion absorption category. And the difference between those two things is this. So they mainly treat the brine from the feed And I explained that problem. And this is why you won't find any of our competitors with big contracts with any of the big existing producers, because their approach is to replace the ponds, which was my initial approach too. I mean, when you see these ponds, it's just like a logical, this is ancient technology. But that's what the pivot that we made, and our technology is able to be complementary to the pond. So their technology is an ion exchange or ion absorption technology, and I'll explain what that is. So they pretty much have these large like cylinders with beads that absorb the lithium, and then they take the beads out, and then they have to apply chemical reagents to leach the lithium out of the beads, and then they have to use a lot of fresh water to wash the beads, and then they put them back in the columns and then do it all over again. So it's a batch process. It uses a lot of chemicals, and it needs a lot of fresh water. These areas are scarce in fresh water. It's obviously environmentally harmful to use some of these leaching chemical reagents, and it's a batch process, which is obviously much slower than a continuous process where the brine just continuously feeds through the membrane. So those are some of the competitors. And one other point that I actually want to make here is that I don't want to say that our technology is the only one that will work and those will never work. And what needs to be understood here is that this is a relatively new kind of sector and niche in direct lithium extraction, because it's a problem we're just starting to face, like I mentioned, with the demand of where lithium is going. And what we're actually exploring is a potential that we could work with some of these other competitors, these ion exchange or ion absorption, to be that first piece of the technology. So I mentioned that we separate lithium from magnesium extremely well right now, and that fits into the pond cascade. And we're developing these lithium sodium or lithium potassium separation membranes. But until we do, we can actually partner with some of our competitors to create a full solution that replaces the ponds. Now, the big companies don't want to replace the ponds yet, but for some of these junior miners, that's a solution that they're looking towards.
I think it's really important details about the differentiation. I appreciate that, and I know that there are quite a few people interested in knowing about that. Another question that we're seeing a bunch of people ask is around intellectual property and your tech licensing through Tech Transfer Office of Texas. Can you talk a little bit about as much detail as you can, but could you talk a little bit about the intellectual property landscape and what your licensing looks like?
Mm-hmm.
Specifically, I guess, how much of it is owned, yeah.
So back in 2018 was when I found the first published paper that was surrounding these lithium separations using a nanoparticle called metal organic frameworks. And it was a paper that was published between the University of Texas, Monash University in Melbourne, Australia, and CSIRO, which is the Australian National Laboratory System. They are joint inventors on the first patent. So I went to that interinstitutional collaboration and licensed our first patent. We were then able to figure out that there were more inventions around the nanoparticles that are embedded in the membranes that actually cause the separation. So we have a license for 4 patents from the University of Texas that manages that relationship with those 2 other institutions. That license is worldwide and exclusive and in the perpetuity of the patents. And they also have government funding, so they're never able to sell the patents to any other competitor that, say, wants to pull the rug out from underneath us. I then realized that we were using a nanoparticle that was patented by somebody else. So the actual base composition of matter was patented by somebody else. So I went and licensed that so that we have complete freedom to operate in what we're doing. So that was the 5th patent. And then we have subsequently filed additional IP, 5 more patents around other various methods and processes and technology that we're working on around this space. So we have a portfolio of 10 patents now between licensing and owning ourselves.
Awesome. Thank you so much for that, Teague. And we're just going to keep going along the potential investors' questions here. So how does EnergyX earn money? Can you tell us a little bit more about the revenue model?
So we are positioned as an energy technology company around our IP. We've come up with some pretty innovative inventions, but we don't want to be a manufacturer and have to put up immense capital costs to manufacture these products. So we partner with a manufacturer that is one of the most experienced in the world, one of the biggest water technology companies and membrane manufacturers in the world, Suez Water Technology Solutions. They are based in France, 80,000 person conglomerate, about $20 billion market cap. They bought GE Water for $3.2 billion about 2 years ago. So they will be our mass manufacturer of the membrane as well as all the ancillary equipment. And when that system gets sold to a customer, like a lithium producer, we will split some of that profit, where Suez takes the lion's share and we take a minority of the profit of the sale of the actual equipment. But then where we make our actual money is in a technology fee for every ton of lithium that the lithium producer produces. So the best way to think about this is an analogy in fracking, right? If the big oil and gas companies like Exxon, Saudi Aramco, et cetera, have these oil wells and they're producing X amount of oil, say 1,000 barrels of oil per well, and then fracking is introduced, which increases it to 5,000 barrels of oil per well. We would hire another manufacturer to make the actual fracking device. We would split the profit when that gets sold to Saudi Aramco. And then for every barrel of oil that is produced, we would take $5. So it's like a licensing technology royalty on every ton of lithium produced using our technology. And we'll look to do those deals for between 10 and 20 years so that we have an annual recurring revenue stream.
Great. Thank you so much for answering that. For the potential investors asking about exit strategy, I tend to save those questions for closer towards the end. It kind of feels like a more natural flow, but I will get to those. Next question here: how long do you see lithium dominating the battery industry? Do you see hydrogen surpassing lithium in the future? And then I think we can actually kind of dovetail that question with, let's just go with that. Sorry, I can't find another question I wanted to add. Yeah. How does lithium batteries compare to sodium sulfur batteries in terms of cost and efficiencies? So how does hydrogen fit in? How long the domination? And then sodium sulfur.
Yeah, I see these questions. So as far as lithium dominating the battery industry, lithium is here to stay. The reason being, and this actually plays into the second question, is it's the lightest metal on the periodic table. So its inherent chemical properties make it very advantageous to be in batteries. And lithium is really a common denominator amongst battery architectures now and pretty much all the battery architectures of the future. So if you look at the next generation, a lot of people are working on solid state batteries such as QuantumScape. That uses a pure lithium metal cathode, which is actually more lithium than lithium ion. After that, people are looking into lithium sulfur batteries. And after that, people are looking at lithium air batteries. And this kind of roadmap that I just gave you actually came straight from LG. So that's their 20-year roadmap on battery architecture, and all of them contain lithium. So as far as lithium goes, being in batteries, it's here for the long term. Now, how do I see hydrogen surpassing lithium in the future? I think that it's kind of that macroeconomic trend of, well, we've already invested so much in lithium and battery infrastructure and charging of battery infrastructure that it's here to stay. You can make that same argument for, well, lithium batteries were introduced in the 1980s, but it's taken 40 years for them to really take a hold in electric vehicles and in energy storage systems. But if they're so much better, then why haven't they replaced oil and gas, right? Because these things take a long time. And even if the best hydrogen systems are introduced tomorrow, or something that is feasible in the long term, it'll still take a really long time for hydrogen to replace lithium. I just don't see it. I see it as kind of like the Blu-ray versus DVD. Like, our society has chosen the path of lithium batteries, and personally, I don't really see a future in hydrogen. Now, if you're just thinking like, well, what could replace lithium in the future? First of all, I think lithium will be here for the next, 50 or 100, however many years. But I think if you're talking about things to replace lithium, you could talk about nuclear fusion and things like that. Now, do we want to drive around in nuclear fusion powered cars? Like, maybe, but I don't know. And then how does lithium batteries compare to sodium sulfur batteries? So the main thing is where lithium stands on the periodic table, and it's the lightest metal on the periodic table. So for electric mobility, where weight is a key factor in energy density, you want to have lithium. Now, as far as stationary storage, other battery architectures could become prevalent, and then it just becomes an equation of economics and what is ultimately the lowest cost of energy storage when weight is not a factor. But I think that with all the investment that we're putting into lithium, it's a different manufacturing process to make sodium sulfur batteries than lithium based batteries and every lithium category of batteries. So there's obviously cost associated with the development of those types of manufacturing processes. And I think that lithium will be the choice of stationary storage in the future as well.
Thank you so much for that. We got through a couple of really good questions there. And then again, holding off on exit strategy, but in terms of progress and traction, when is the first installation planned to go live, and what are the risks that you see? And then I think when we're talking about progress in future applications, it kind of can tie into what are your future capital needs, and how do you plan on raising the funds? I want to be delicate with that last question, the way that we discussed before the call.
So when is the first installation plan to go live, and what are the risks? So right now we're at the pilot phase. So right now we're testing real brines that have been sent to us by these customers that we've signed agreements with in our laboratory. And there's obviously constraints on testing stuff in the laboratory, and that's why the next phase is in-field pilot plants, right? But we have systems in our lab that have been testing real brine for up to 1,000 hours. That's a big milestone to achieve stability of these membranes for 1,000 hours. The first pilot plant is planned to go live this summer. So in these agreements, with the results that we've gotten, we're looking to deploy these pilots over the summer, and we'll probably look to deploy 3 pilot plants this summer with separate customers. The reason for pilot plants is because we need to test our technology in the field for 6 to 12 months. 1,000 hours is good, but we need to make sure that there's stability in the membranes for 6 to 12 months before we can even consider building a commercial plant that costs, $10 to $15 million or somewhere along those lines. So the risks that I see associated with our first in-field pilot plant is really the stability of long-term testing. It's just something that hasn't been tested yet. We've proven everything in the lab in terms of these membranes work in that lithium is passing through and unwanted ions or salts are not passing through. So we're creating a purified, concentrated stream of lithium that is much higher than anything that's ever been achieved. And we've tested for 1,000 hours on sheets of membrane that are like paper size, but we need to build stacks of those that are 20 high and put that in the field and run for 6 to 12 months. So scaling risk is the next risk with the pilot plants, but most, if not all, of the technology risk, like do these membranes do something that has never been done before? That milestone has been crossed.
Thank you so much for that, Teague. And I know we have about 14 minutes left scheduled on this, so I want to be hyper diligent of trying to get to all of your questions. Thank you so much for the participation from the attendees. Love to see this engagement. And do remember, you can always go to netcapital.com/companies/EnergyX and learn some more there and invest directly into this company. Before I go into the exit strategy, because it seems like there's a lot of interest in that, I think I would be remiss not to talk a little bit more about the rest of the team. So it's great to learn about you, Teague, but investors are always interested in knowing about the team. So can you tell us a little bit more about Bob and the doctors on your team?
Yeah, so one of the most important people is the professor at University of Texas, who is the chairman of our science advisory board and the inventor of the original IP. His name is Dr. Benny Freeman. He's pretty much one of, if not the most renowned membrane expert in the United States, if not the world. And, he invented this technology in association with Monash and CSIRO. And he's also an investor in the company. And I think that says a lot about his belief in me and the company, that the inventor is willing to put forth his own personal money into the company. You don't see that very often. So he's been instrumental in some of the commercial and scaling partners that we've brought on. Just his reputation alone, I pretty much credit with our partnership with Suez. They said, "Oh, you're working at Dr. Freeman's lab at University of Texas. Like, we're very familiar with his work. Like he has a $10 million grant from the DOE for his center at University of Texas, which is materials for water and energy technologies. Like, it doesn't get better than that." So he's the first person. The second person is our CFO, Bob Woke. And, Bob is kind of the gray hair of the company, for lack of a better description, but he's worked in the industrial gas industry for 30 years at large companies like BOC and Linde. These are companies with multi-billion-dollar balance sheets in senior financial positions, and he's worked on big projects. And he's really brought kind of a conservative approach. I would consider myself probably more aggressive with my timelines and expectations and negotiations. And so he's really balanced me out in that. Our VP of technology, we got from Rio Tinto. Rio Tinto being the second biggest mining company in the world. They're 100 billion in market cap. Amit Patwardhan, I think he has 4 degrees. I think he has a bachelor's, a master's, a PhD, and an MBA. And he was the director of global innovation for Rio Tinto for 12 years. So he's leading our technology side. And then underneath Amit, we have a variety of PhD students in director of battery design, director of membrane engineering, director of MOF chemistry, director of electrodialysis. So pretty much you have to be a PhD to work for me on the science side.
That was great, Teague. I appreciate that description. And in the interest of time, we're just keep firing along here.
Fire off.
Can you talk a little bit about the market size? And so do you have an idea of how much lithium is consumed globally? And are there any growth projections that you cited on your offering page?
Yeah, so last year, the total demand for lithium was about 300,000 tons per year, maybe a little bit more, but it was around 300,000 tons per year. By 2025, conservative estimates have that at over 1 million. And this is all, of course, tracking electric vehicles. Like, if you believe that electric vehicles are the future and that auto OEMs are going to transition their fleets, then lithium is one of the most important cogs in that value supply chain. So I think that it's going to be higher in 2025 than 1 million. I think it's going to be around 1.5 million. But then after that, 2030, 2040, you're looking at multiple millions of tons per year. So the market for lithium is absolutely huge. It's purely driven by electric vehicles. So, a lot of these companies are talking about electrifying their fleet. GM is looking at the Hummer, Ford is looking at the F-150, Mercedes has 20 vehicles, Toyota has 8 vehicles. Like, they all have plans for electrification. How quickly they're able to do that somewhat depends on lithium supply. So but the market is growing massively right now.
Very, very important. Thanks for the potential investor that asked that. Let's make sure that we cover this, because a handful have asked. What are the exit strategies? What's the plan? Are we going public? Is it a private exit? Your private equity?
Yeah,
what are you thinking?
Look, there's a lot of exit strategy potential on the table right now, especially for a company in our segment. Tesla offered to buy a direct lithium extraction company a handful of years ago for $325 million before they even had revenue. I think they might have had one pilot plant in the field. So, you could look at our customers as potential acquirers, being like Albemarle, SQM, like these companies that are going to be paying us tons of money for this royalty. Albemarle is a $15 billion company. They could look to acquire. Big battery companies could be looking to acquire, like the Samsungs, LG, Panasonic, CATL, or big auto OEMs, Mercedes, BMW, Volkswagen, Tesla. Those are potential acquirers. On the other side, I think that, I'm pretty capable at raising capital, and that we'll try to increase the valuation through subsequent private financings. But we're in a really hot, I'm sure most people here have heard of this, heard of a SPAC, right? And I wouldn't count out going public or doing a direct listing with a SPAC. I just read an article that there's 225 SPACs that were created in 2019, and they have a 2-year span to find a company to take public. And they're literally fighting over companies to be able to take them public. And we've all seen what's happened with QuantumScape and other companies that are in the renewable energy sector. So I think that there's no shortage of exit strategy here. And my number one consideration and goal is to make a return for shareholders. I think that's the most, other than building the company and creating a really valuable product, creating value is what you have to do, whether it's for the shareholder or for your customer. So that's something that's certainly top of mind.
Yeah, absolutely. A lot of options. And just for those who might not be super familiar, SPAC being a special purpose acquisition company, we're seeing a lot of activity in that space, especially through 2020. Fantastic. Couple moments here. Somebody was asking there are some specific questions about the membrane and Gen 1 system. Is the plan to go into producing your own lithium batteries, or is the plan to maintain just as a supplier to the battery operators?
Yeah, so right now we want to look at ourselves as an energy technology company. Very, very minimal capital requirement, right? We have partners to make the equipment and the membrane. Producers produce the lithium. Then we take the royalty. There are scenarios where people are trying to get me to joint venture on lithium resources, in which we would own some of the lithium. and that could then be vertically integrated into battery manufacturing. I mean, I have a 10-year plan on my website that you can read. You know, I took a page out of Alon's book there, but you know, we make this technology right now that is very specific to lithium extraction and production and recovery. The second product we're working on, which is about 10% of our bandwidth, is the solid state electrolyte, which is one very important piece of a solid state battery. If we can get that to work, that could be paired with a lithium metal anode, which is potentially something that would be produced using the lithium that our customers produce, or we could produce if we owned a resource. And then, you know, we would just need to source the cathode, which right now cathodes are looking to be typically NMC, which is nickel, manganese, cobalt, or LFP, which is iron phosphate, which is what Apple is considering using. But we could source that cathode. I mean, we overall want to be an energy technology company. And I really look at what Tesla has done, and they've vertically integrated the supply chain. They've squeezed out margin. And we're going to continue to try to develop our initial products, which will, you know, put us on the map. But then after that, you know, the future is limitless.
Awesome. Thanks for that, Teague. You know, I think there are a handful of other questions still in here. Do remember you can go directly to netcapital.com/companies/EnergyX to invest and learn more. I'm old school. The people who have listened to me do these presentations in the past know that I like to end in a specific way. So Teague, why should the people listening right now and the people who end up watching the recording go directly to netcapital.com and invest right now?
Well, first of all, let me say that, you know, there's still a bunch of open questions here, and I've been answering all of the questions on the discussion board on the offering page. So if you go to that link, there's a little discussion tab. And if you just ask the question there, I'm more than happy to write an answer. But why should you go there and invest right now? Well, because there's only so much space left in this round of Netcapital before I close it up. And we have some really serious investors that are looking to fill out the rest of this round. That is this is part of a $10 million Series A round. And then even after that, we have interest from investors already looking towards our Series B. And, you know, I'm going to give a very, very healthy return on the people that believe in me from this early stage. And above that, we're going to create, you know, products that provide value to the renewable energy segment. And, you know, this is a really big problem that we're trying to solve. And, you know, we have some incredible technology that a lot of the biggest lithium producers in the world are already testing and interested in. And it's going to be an exciting journey.
Oh, well, thank you so much for that, Teague. And we didn't even get to scratch the surface on your relationship with Logan Paul and all those fun things from the Impulsive podcast. But we did get to take a deep dive on the science. I love that you're able to provide that for us, and I hope that created value for the potential investors on this line here. So thanks again for everybody attending this webinar. Thank you so much, Teague, and the rest of the EnergyX team to help put this together. Obviously, as always, you can go directly to netcapital.com and search for EnergyX, or netcapital.com/companies/EnergyX to learn more, ask any questions on the discussion board, and invest directly in this company. With that being said, I hope everybody enjoys this new year and the first webinar of the year. Thank you so much for everybody for attending.
Thanks, guys.